Hello. This is day 3 of Unit 5, but this is really Chapter 11A, all about exponents. And we're still on exponent properties just for more practice to see some more different types of examples and use of properties. It's good to have one of these like charts just for quick reference because we really ought not to need to use a calculator for many of the stuff, and a lot of it is variables, so you can't really anyway. So, screenshot or make your own or whatever. All right. So some of these problems have use of multiple properties, and there are multiple ways to solve them if you use, a different one of the properties first versus a different property first. But this first one, I'll make it a little basic and just describe this as, in the parentheses, you have s to the fourth, t to the seventh, and exponents just mean 4 s's multiplied to each other times 7 t's multiplied to each other. And so you could write it out if you really wanted to as s times s times s times s times t, and you get the picture. And then it's to the third power. Alternatively, so this third power means actually there are 3 of these parentheses also multiplied to each other. But it can be a little bit easier than that because we already know one of the basic properties. We've seen it a little bit. Is that maybe I just write this as s to the fourth times t to the seventh, and then there's 3 of these. So s to the fourth times t to the seventh times s to the fourth times t to the seventh. And we won't really need to expand all these like this, but I'm just kind of showing where this property works. We had 3 of them because of this exponent of 3. And we know that, all of these terms are just being multiplied together. So the commutative property would hold. And we would say, well, it's just s to the fourth times s to the fourth times s to the fourth times t to the seventh times t to the seventh times t to the seventh. And again, that's the commutative property. I just rearranged them so that the ones that could be multiplied together are next to each other. And s to the fourth, that just means s times 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 s. And so the property of when you multiply a term that has the same base as another term, so they both are base s, you can add their exponents. So this would be s, 4 plus 4 plus 4 is 12. T, 7 plus 7 plus 7 is 21. So this is the answer we get. But if you remember, there's also a property called power to a power. And if we have, s is raised to the 4th power, so 4 is a power of s, but then 3 is a power as well, raising 4 to a power. So s is being raised to the 4th, and then s to the 4th is being raised to the 3rd, power to a power. When we have that, you can multiply your exponents, because the multiplication is just repeated addition anyway, which is what we did right here. So s to the 4 times 3 power is 12, t to the 7 times 3 power is 21. So that's the quicker way. Power to a power if you can. This next problem, I see that there's really nothing to simplify on top. X and y aren't the same base. I cannot add their exponents together. They're stuck. I do have an x on the bottom, and I have x's on top and bottom, so I could subtract their exponents eventually, or eliminate them because the same thing on top and bottom can cancel each other out. But this bottom x is not freed up yet because it is being raised to a power. So order of operations would say, well, before you divide, we need to do exponents. So we can use power to a power here, and this bottom term then becomes x to the 2 times 4, which is x to the 8th. On top, we have x to the 3rd and y to the 5th. Now, I'm kind of a fan of not subtracting the exponents. Okay, again, this is the division property where you have x to the 3rd divided by x to the 8th. Both the same base of x, so we can subtract their exponents. Here's what happens if you do that. x3 minus 8 is negative 5, and then y to the 5th. But now we have the negative property of exponents saying this little guy is on the wrong side of a fraction. This thing doesn't look like a fraction, but it is. And so it should be on the correct side of the fraction to make the exponent positive. So this would turn out to be y to the 5th over x to the positive 5th. When it moves positions on a fraction, it goes from top to bottom or bottom to top, it changes the sign of the exponent. So we made it positive. Good. This is the right answer. I don't like ending up this. I don't like this extra step, frankly. When I subtract and I get a negative, then I have one more step to move it to the bottom. So I prefer when I get to a spot like this, is I just think, well, I'm going to cancel out all the things that the top and bottom have in common. There are 3 x's multiplied together on top, and again, I could write them out. I'm not going to do this. I'm just going to think about it in my head. 3 x's, and there's 8 x's on the bottom. X times x times x times x times blah, 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 blah. But 3 of them from top and bottom are going to eliminate each other. So 3 are gone, 3 are gone. How many x's are left over on the bottom? 5 more, because we took 3 away from the 8. 3 of the x's on top canceled with 3 of the x's on the bottom, leaving 5 x's on the bottom. It's already on the bottom. There's no negative exponents. So this is y to the 5th over x to the 5th. Again, same answer. You can do it either way, whichever way you like better. I just stated my preference. I like to think of them as canceling them out instead of subtracting the exponents. But whatever. This next problem, and these are all the examples for the day. This next problem, we kind of see power to a power property again. 27 doesn't look like it has an exponent, but it does. It's a 1. So 27 to the 1 times 1/3 power. 1 times 1/3 is 1/3. So 27 to the 1/3. And then a to the 6 to the 1/3 is 6 times 1/3. Power to a power multiply. So a 6 times 1/3 is 2. So a squared. The only other thing is that we can mess with this number to the 1/3 power. Remember, an exponent that's a fraction can also be written as a radical with the index of 3, so it's a cube root, 27. And then the 1, the numerator, means the exponent of everything. And 27 to the first power is still going to be 1, or cube root of 27 raised to the first power is still just going to be the same thing. So the first power is kind of inconsequential. So cube root of 27 is really just asking what number to the third power is 27? And on our chart at the top, this is how you use it. What number to the third power is 27? There's 27, third power. So what number? 3. So this turns into just 3a squared. So we just used power to a power property, but then we also had to use the fraction exponent property where it turns into a radical, and then we take the root of it. We were able to. This next one's tons of fun. I would suggest, and I'm not sure which way is the best, it's just whichever way you see of something that you can do. Maybe you want to start on the bottom. You say, hey, this thing's power to power. I can get that done right now. Sure. 3 times 4 is 12, so a to the 12th on the bottom. And we could do that to all of them. I mean, 3a squared. They both have exponent of 1, so 3 squared a squared. 3 squared a squared. And 3 squared is going to be 9. I can simplify that if I want. And then I see this 2b to the negative 5th. I could do the same thing I just did with the 3a, give both terms this negative 5 exponent. But I don't like messing with the negative exponents. I mean, maybe that's just me, but this whole chunk has a negative exponent. I could move it to the bottom, and it would then have a positive exponent, 2b to the positive 5. And now I've taken care of it. So we kind of pieced together multiple things. So maybe we should rewrite this and just see what we got. 3 squared is 9. I can write that. A squared on top. Nothing else on top. Then we also have a to the 12th. And then we could simplify 2b to the 5th. It's 2 to the 5th. Do that in red. This thing would become 2 to the 5th. B to the 5th. That's 5. And then 2 to the 5th we know is 32. So 32 b to the 5th. All right, almost done. But we should recognize, you should always look for this, because it's one of the easy things to recognize. It's like a little matching game. Do I have anything that matches the top as with the bottom? Mainly, they both have A's. So 2 A's on top, 12 A's on bottom. If I canceled all the ones they had in common, 2 of them from the top would disappear, and 2 of them from the bottom would disappear. There was 12 to begin with, though, so canceled out 2 of them, I still have 10. And this is simplified. I'll write the number first. It's typical. 32A, 10B, 5. And again, it looks like I'm just rearranging things down here over and over again, and that's fine. They're all being multiplied together, so that's just the commutative property. We're just used to seeing numbers out in front, coefficients, and then typically alphabetical order of variables. But that's really all there is to it. Notice that there were multiple avenues to go on this guy. We could have done things a little bit differently, perhaps in a different order. But the top of a fraction and the bottom of a fraction are considered grouping symbols, their own grouping symbols. So I just elected to do all the top stuff first, all the bottom stuff first, simultaneously, and whatever. All right, hope this helped. This was just more practice on some exponent properties. All right, good luck.